All right, so hey, I'm Todd McDowell. I lead our data center switching product management team for the HPE Aruba side of the house. I'm going to talk mostly about our CX switches, which are part of the HPE Aruba networking line, and how they integrate in with the rest of the HPE solutions. And we're going to kind of step through a little levels as we go through here in how they kind of go from just standard switches to becoming better together with the rest of the HPE portfolio. Standard disclaimer, I don't think I have any roadmap stuff in here, but if we do get into some discussions and we mention things that are roadmap, just understand they're subject to change, not necessarily formally committed, et cetera, et cetera. Before we go through the agenda, from a logistics perspective, if we have time at the end of the session, we'll open it up for Q&A, but we'll try and keep it at the end because as the mics move around, we may not make it in time and kind of cuts into your time here. So from an agenda perspective, we'll go through the secure AI-ready network, some of the HPE integrations that we have, what we call better together. We'll talk briefly about edge data centers and how that's important and some of the things we're doing there. We'll spend some time on the CX 10000 series products and our distributed services architecture. And then we'll go into some of the HPE Morpheus VM Essentials integration. And then we'll kind of put it together all at the end, kind of bring it all home with a little use case example around ransomware remediation. And then we'll call it a day. So with that, the secure AI-ready network. So I think if you saw the keynote, you saw we kind of cleave it up into two different things. There's AI for networking, and there's networking for AI. So the AI for networking is really all about pulling information out of the devices on the network so that we can take that information, distill it, digest it, and make intelligent decisions about the network and self-heal it, self-drive it, things like that. The other side, the networking for AI, this is really about fast fabrics, high bandwidth, low latency. As you heard in the keynote today, not just within a given data center, you've got to connect it together. So things like data center interconnect, the routing side of things, really bringing those pieces together in big, fast pipes. We're not going to spend much time on that today. We'll talk a tiny bit about it. We'll focus more on the other side, the AI for networking. And of course, bringing it all together to give you these secure AI-ready networks. With that, most of the discussion we talk about here today, again, will be on CX. Not to say that the QFX side, the Juniper portfolio, won't play in here. It will absolutely play in over time. We've spent a lot of time on the Aruba side of the house integrating with the HPE full stack. That will happen as well on the Juniper side. But again, today there's a few other sessions. Hopefully you've attended those on the Juniper and the Apstra side. We'll focus most of the time here today on CX. So kind of breaking it up into three different pillars. If you've seen our story before, the Edge Services Platform, kind of connect, protect, and automate. That's really the mantra that we're sticking with. It's really in support of that secure AI-ready network. So as it pertains to the HPE Aruba switches, a high-performance switching fabric. Today we can build 10 to 400 gig fabrics. We had plans to go up to 800. The acquisition happened, so we'll take the 800 and the 1.6T and leave that for the Juniper, the QFX portfolio. From a protect perspective, this takes a couple different shapes and forms. Anywhere from DPU-based switches to do things like microsegmentation, distributed firewalling, and then your standard other normal security policies. But we'll focus most of it around the 10K and what that brings to the table. And then from an automation perspective, taking this data that we can pull from the network, real-time, non-sampled telemetry data from the 10K, and have that become that fuel for the AI ops in the rest of the network. And so we'll kind of, go through this step by step as we approach through, but that's really, what we've been talking about for the last, 4 years since I've been here. Even though the tagline at the top changes a little bit, the tenets that make it up don't really change. They're the fundamental attributes for, any healthy network. So if you saw the keynote, you heard Antonio talk about the performance gains, with the new generation, the Gen 12 servers. If anybody here is still on Gen 8, you've got a 26-to-1 improvement ratio running the new Gen 12 versus the older stuff. So the punchline here is no matter what generation you're on, if you're prior to Gen 12, you'll see significant improvements in your compute infrastructure by moving up to the Gen 12. That has real life impacts as it pertains to rack space, power, cooling, all those attributes. So you can do a lot more with a lot less, which all of us, I think, are asked to do every day. Why not have the machinery do it as well, too? Do more with less. So obviously, that's a great piece of the puzzle. But we still have to adhere to the laws of physics. So the more that we kind of consolidate and crunch something down on one side, we pay for it a little bit on the other side. So how we're paying for it is to get that level of performance, crunch everything down into a very condensed high performance form factor, we have to have a lot more bandwidth in that device. And a lot more bandwidth means the networking side has to grow up to support the bandwidth, the interfaces. Could be 100 gig, over time 400 gig interfaces coming out of those servers. So that usually results in an update in your infrastructure. You can certainly get them with 10, 25 gig interfaces, but if you've got these high performance compute modules, let's up the network as well too. So we'll talk a little bit about how we're doing this with our CX switches. I show one down here. It's our 400 gig 9300. The little curly Q up top is some innovations we've done with cabling to get you a higher fan out without using breakout cables. So we can take a 32 by 400 gig switch, and we can get 128 100 gig ports out of it without using breakout cables, just with the use of what are called VSFF, or very small form factor optics, and patch cords instead of breakout cables. So a lot of innovations that we've done there, but moving to these high performance servers allows you to do a lot of things that we'll talk about later as it pertains to VMs and kind of right sizing your virtualization estate and getting more out of your money. The end result here is do more with less, and of course hopefully pay less overall in doing so. So this is, looks like a spider web off to the right side, but this is really, what we can build as far as a 400 gig fabric with our 9300 series switches. Just as a highlight, we'll talk about some more of our portfolio, but we've only got 45 minutes here to kind of cover everything. So I'm not going to give a full portfolio overview, just kind of show what we can build today. We can build a fully non-blocking 400 gig fabric, 9300s as your spine, 9300S as your leaf switches. So the 9300s are 32 ports of 400 gig. The 9300Ss are 32 ports of 100 gig with 8 ports of 400 gig uplinks. The 9300S also supports MACsec. So you can now have a secure fabric too down into your end devices should you require that. We also have an option where we can use the 9300s as a leaf switch as well if you have higher density 200 gig or high bandwidth adapters 400 gig if you need that as well. The key point here is you can kind of mix and match and build a very high performance network with the CX switches. Moving above the 400 gig, this is where you're gonna jump into from an absolute perspective the QFX portfolio. If you have other needs or reasons to move into the QFX, they'll support everything that we do on the CX product line as well, with the exception of two products which we'll cover here today, the CX 10000 and the 8325H. Otherwise, it's kind of left hand, right hand, pick the solution that is right for you. So we'll start talking about some of the integrations that we have within HPE, and if you're familiar with the HPE offerings, there's a lot of different ways you can consume this. Whether it's private cloud enterprise, private cloud business edition, service packs. There's a whole bunch of different ways that you can consume the products in a way that's right for you, both from a solution perspective, from a payment perspective. Kind of, I won't say sky's the limit, but a lot of different ways here. The key part here is the CX switches are generally incorporated into most of these solutions, and there's reference architectures to back them up, dozens of them, whether they're 8300s or 9300s. We'll kind of go through some of these use cases, 6300s or 8100s for out-of-band management. you know, from a storage networking perspective, really the focus here is on some smaller form factor switches that we'll talk about. Also having lossless fabrics using things like DCB and ECN to really allow that network to perform in a lossless manner, not drop any packets. You can consume the switches on a SKU-based perspective as a service. So through service packs, you can buy your data center top of racks and use it as a service. Again, many different ways to consume it and many, many different customer logos that are consuming it this way today. We'll really talk mostly about the 9300s, which we did already, the 8325s, and the 8325 100 gig and 8325 25 gig. These are really the ones that make up the bulk of most of these full stack solutions. So don't be surprised if you get something and it has something else. But generally speaking, these are the ones that we integrate everything in with. There are even some solutions where you don't really know you're getting a switch because we embed the switch in with the solution. So the good news there is you're not going in and having to configure it. That solution does the configuration of it for you as well too. So it's kind of abstracting out that network connectivity and just providing it in an embedded fashion. So all of this is, I think, easy to talk about, but there's a lot of work that happens in the back end. So each switch that we kind of put into these individual solutions can take 9 to 12 months of qualification on the back end. So sounds like a lot of time. The end result for you is if you get one of these solutions that have a switch qualified in it, know that we've done the work on the back end so that you're not having to pull it out, have a DIY experiment or a science project, dropped off on your doorstep that you're responsible to do everything with. We have a matrix called SPOC, which stands for Single Point of Connectivity Knowledge, that basically maps anything from the operating system on the compute node to the adapter driver, to the right NICs that are supported on this, to the switch, to the storage arrays, and kind of end to end gives you that viewpoint of knowing that we've tested each of these things along the way. From a, if you're a partner from an ordering perspective or a consumption perspective, we have these integrated into a common tool to allow simple ordering, which again sounds boring to say, but it helps speed up the process of getting the products in. But again, a lot of work goes into making sure that once you get this, you know that it's been vetted, that it's been tested. That's not to say that you can't put something else in and it will work. They're Ethernet-based, it's standards-based technology, but there are nuances that happen, and we try and make sure those all get wiped away before you even see the solution. So we'll talk a little bit about edge data centers, and as we do this, in my mind, I always have this view of this old rustic clock shop that's just full of these old wooden clocks with pendulums kind of swinging all over the place. And no matter what kind of technology you're in networking, there's always a pendulum for that goes from this side to this side, on-prem, in the cloud, high performance, low latency. It's always some counter position here. And the data centers have certainly migrated their way around here. So in the middle section here where we have kind of the enterprise or the colo, that was what we traditionally looked at as data centers, and then the hyperscalers came into being, and they stood up these big, giant, massive data centers, and in came public cloud, and everybody kind of rushed, the pendulum swung that way, and people moved all their workloads to the cloud because that was the way to go. You didn't have to have the network on site anymore. But then things like GDPR, data sovereignty issues, application performance issues, all kinds of other things kind of crept into the mix. And we said, well, maybe we need to start repatriating some of these workloads back so the pendulum starts swinging back the other way. So this is really just to kind of show the different areas of the data centers, going from the super massive down to super small. Maybe it's a rack with a couple switches, a couple servers in it. But the key points here are the two arrows. These are the real counter sides of that pendulum. One is the proximity to compute. Do you need massive amounts of compute? If yes, you're probably going to be in a very large data center of your own, or you're going to be in the cloud where there's just endless amounts of compute resources. But what happens with that is the assumption is, that data is going to exist for a long time and has plenty of time to process and do what it needs to do with that data. On the other side, think things like smart cities, IoT edge, where data has a very, very short lifespan and you need to process that data locally. And so the latency aspect is huge. So this is where the edge data centers really kind of come into play and changes how we build products and offer products to be deployed. And so that's kind of, just the setup here. Of course, their sizing, don't get wrapped up around the sizing. It's more about, what is, the right thing for an edge data center. So I've kind of broken out 3 examples here. One would be a regional edge. This would be your typical, if you're a multinational company, you've got a data center in each of the regions, or maybe you've got colos, or maybe, in Europe, different countries based on GDPR rules and regulations. Kind of standard fare. But if you move to the network edge, these are things like smart cities, where you may have things where your energy or utilities may have a need for processing power at the edge. Maybe you're doing private 5G, you need cellular RAN, centralized RAN capabilities. You've got autonomous vehicles where you need some real-time processing close to the vehicle to make sure that decisions that are being made with the right information. And then you go to the on-premise edge. So think of things like retail, smart retail stores, augmented reality in these retail stores for buying decisions, telehealth, factories, machine-to-machine learning, these types of things where you have really fast decisions that have to happen near real time. You don't need a lot of compute capacity or switch capacity, but you need that at the edge. And so that's really kind of that edge data center that we'll talk a bit more about as we get to the next slide here. And some products that we introduced that are really purpose-built for this functionality. So these are part of the 8325 family. They're called 8325H for half width. These are half rack width wide. You could put 2 of them in the same rack unit. So whether you have a small rack inside a distributed edge, or you're in a colo space, or military applications, these might be in a hardened battlefield carryable case where you've got 2 of these providing you redundancy, a couple of servers, maybe a storage array that's mobile with a couple people carrying it, or if you may have a hyper-converged infrastructure in retail stores. We've got a large retailer in the US that views each one of their 2,200 stores as a data center. It's not a data center with 50 racks, but it has local HCI clusters where they can do on-prem data processing. So this is kind of that real edge data center. So we've got 2 models here, 25 gig capable switch and then a 100 gig switch. So you can use these as the need suits you, as your bandwidth requires. You could even use them as small data center deployments where you're the 100 gig one, it's 16 ports of 100 gig might become your spine, and you could deploy your leaf switches with the 25 gig. And again, each of these 2 can go in a single rack unit. I won't say they're unique to us completely, but there's only 2 vendors building these today. And so these are kind of going off the shelves at a very good clip, and lots of applications that we're seeing customers get very creative and build stuff here. The one thing I will mention is these are redundant from a power supply and a fan perspective, but they're fixed internal. They're not removable power supplies and fans like you might see in a traditional data center switch, just because the half width makes it space prohibitive for us to be able to have removable power supplies and fans. But you can lose a power supply, you can lose a fan, and it stays up fully functioning. You just have to replace the entire switch. All right, let me shift gears a little bit and talk about the CX-10000. Quick show of hands, who's familiar in here with the CX-10000 already? Okay, looks about a third of the room or so. So this is a switch that we announced about 4 years ago, a little over 4 years ago. It's been shipping for about 3.5 years. And it just had a big brother that was announced back in May, and it just started shipping a couple weeks ago. As you heard a little bit in a kind of fragmented manner in Rami's keynote today, It's fragmented because the news came in late and the slides that we do for all this stuff have to be done pretty early. We just did receive on Monday a Product of the Year award for the newest model here that we'll talk a bit more about for enterprise networking. This was from CRN. So pretty cool award for us. The matching end of the book set is 4 years ago, we received Product of the Year for the 25 gig version of this when we announced it. So great news for us, great product that is a great solution for our customers. What is it for those who aren't aware? We call it a distributed services switch. You may have heard it referred to as in the industry as a smart switch. It's essentially taking a regular network switch and adding DPUs inside the switch to do additional data processing. So DPU stands for data processing unit. It offloads some of the capabilities that you would normally take care of in usually an external appliance, whereas your switch would normally be doing layer 2 and layer 3 switching capabilities. Anything above and beyond that would typically go off-site to, or not off-site, off the box into an external appliance like a firewall, like a NAT appliance, things like that. We do some of this internally, and we'll talk through the merits of what we do here. But to kind of paint it out, we've got the two models. One's a 48-port, 25 gig switch. The newest one's 32 ports of 100 with 400 gig uplinks. Inside the smaller one, we have two 400 gig DPUs, and in the larger one, we have four 400 gig DPUs. So in the smaller one, we have 800 gig of stateful services behind the ports, and on the large one, 1.6 terabits per second of stateful services. So if you have two of the larger one in a rack, you have 3.2 terabits per second of layer 4 firewalling for things like microsegmentation for east-west traffic. So that's pretty phenomenal amount of processing capabilities that we deliver in a box that's just sitting at the top of rack. We'll talk about the merits. It's typically about 10 times the performance and scale of a traditional switch. The next slide we'll go to kind of shows the merits of our primary use case, and that's microsegmentation at top of rack. What I don't have on here, I forgot to put it on, there was about a month and a half ago an article in Network World talking about the merits of microsegmentation. And one of the things that I didn't realize, because I don't own a company, is a lot of them have cyber insurance. Having a microsegmentation suite in your network, 60% of the customers found that having that got them lower rates on their cyber security insurance. So there's that. You could save money just by putting this in here on your cybersecurity insurance, plus all the other benefits that microsegmentation brings. So today, we've got it depicted here as a spine leaf network. It's a beautiful network, predictive hop count, predictive latency. Everything's beautiful with it until you want to do things like security. So to secure workloads here, you've got to put in an external firewall, and you now have to hairpin all your traffic over to the far right rack where the firewall resides. So these are pretty expensive firewalls. They're great. You need them for all your perimeter security and the other things that the next-gen firewall brings, but they're not really designed, nor is this network topology designed as a bolt-on thing to kind of hairpin everything over there. You're adding effectively double the traffic across your spine. The security solution doesn't really scale linearly. Once you exceed the capacity of that firewall, you got to buy a new firewall, and that is very expensive. So this 10,000, the CX-10000s, allow us to take those capabilities, distribute it across to the top of rack switches that you would have anyway in your data center, but we offload those security policies onto those switches and do the microsegmentation there. So you don't have to do macro segmentation or zone-based segmentation in a firewall. You're now doing it in the switch. There's an opposing way to do this, and that would be by deploying agents on your servers within the racks. That is a bit laborious. You now have to manage and pay for an agent on every one of your servers. You now also have to consume CPU cycles on your servers to support these. So there's some estimates out there. If you're doing like distributed firewalling with NSXT, it can consume as much as 25% of your CPU bandwidth. So if for every 4 servers you deploy, you have to deploy a fifth one just to make up for that bandwidth that you've lost on that agent. So whether it's 10% or 25%, it's valuable CPU cycles on your servers that you're losing to do something that we can do in the top of rack. We just had the CX10040, the 100 gig version in Supercompute 25 last week in St. Louis, and we were going head to head against firewalls, and we performed at 99.999% throughput for layer 4 stateful firewall inspection on a 400 gig port. So head to head against a Palo Alto or a Fortinet firewall in the price footprint of a top of rack switch. So it's pretty cool. Price economics, it's about 53% lower than either an agent-based solution or an external firewall-based solution. Plus, you get the other capabilities we're not going to go into today, but these stateful services that we offer in the DPU can also provide and usher in other use cases as well. The other use case that I won't say stumbled across, but as we got into our deployments with customers, in addition to the microsegmentation, the use case that started to resonate the most, and this ties back into the AI ops part, is the telemetry. So we're sitting at the top of rack, we're doing inspection of every packet that comes through that data center, and in doing so, we can now export that telemetry information off and have third-party applications or even our own applications take that data and do something with it. So by taking the 10K and exporting off this non-sampled telemetry, so we can take full streaming IP fixed data, not sampling one out of every 10,000 packets. We can do every packet, send it across to a data lake where you're now going to go ahead and sort through the information, pass it off to a downstream appliance. The classic example that we use as I would say our predominant use case is a partnership we have with Akamai Guardicore and their segmentation suite, where they can take the telemetry information that we export out from the 10,000, they can digest it, offer up a set of rules based on what they have seen from the flow data. So they can basically say, we believe you should install these policies on the switch based on the flow and telemetry data that we've seen. And through the API integrations, forming a closed loop, we can automatically reconfigure the CX10000 to set up policies based on the flow data that we had exported and that the Guardicore segmentation suite had offered up as rules to configure and microsegment the network based on the telemetry data that was seen. So that's kind of a classic use case that we discovered just because we were able to export all this telemetry data off and working with our third-party ecosystem partners to provide kind of a real life AI ops zero touch solution using the 10K to make all of our lives a lot easier. The other one that we've kind of walked into because of something that another vendor did was allows us to participate in VMware disenfranchised customers, where I'm sure anybody who's deployed VMware here has experienced a bit of sticker shock somewhat recently. Most of the customers that we talk to have seen anywhere from about a 2 to 4 times increase in the price of licensing that they were paying for their VMware. Network World did a study. They've actually seen some customers had a 1,500% increase. That's more of an anomaly, I think, but we see about 2 to 4 times as the typical increase in cost. So quick show of hands, folks impacted by the VMware price increases? Few. So there's kind of not much you can do with it, or at least historically there hasn't been. And so about a year and a half ago at Discover Las Vegas, last calendar year, we announced HPE Morpheus VM Essentials as kind of our solution to start helping customers migrate away from their pains that they were experiencing with VMware. And so we've continued to mature that solution. And this allows us to, or allows our customers to come up with a plan to address the high prices with their virtualization suite. So you can make the choice, move towards HPE VM Essentials, And the VM Essentials Manager allows you to monitor and control both your VMware estate as well as your VM Essentials estate too. So you can kind of have a migration plan and path to get away from VMware over time to a new virtualization suite. VMware's charging the new licensing is per core per year pricing, and then there's add-ons on top of that. The VM Essentials is per socket. So from a pricing perspective, we'll go through the numbers. My numbers are slightly different than what Antonio showed in his keynote. He said 90% decrease in price. I've got 80% plus, and we'll kind of walk through some of the numbers here. But we give you a couple pathways to do it. One is to kind of go all in what we would consider the strategic path, and say, hey, I'm going to make the move, go to VM Essentials, migrate over time out of my VMware estate. And you'll do this with starting to deploy VM Essentials, use VM Essentials Manager to dual manage your VMware estate. You'll use the plugins that we've created for the CX10000, so you can now use the VM Essentials Manager, create policies that get instantiated into your CX10000 and offload some of these capabilities and allow the 10,000 to be your policy enforcement point. Or you can do more of a tactical approach where you're like, hey, I'm not sure what I want to do VM Essentials wise yet, but I know I need to do something around microsegmentation. If you're using NSXT and distributed firewalling, I know I got to get off of that. So we've got a customer that we like to kind of showcase where it was an 8-week sales cycle from the time we started talking about the 10K, uncovered that they were getting hit with the VMware cost increases, and then when they purchased the 10K, that was an 8-week cycle, and in an 8-month period, their cost savings of getting them back down into the VVF license paid for the CX10Ks. So they bought 8 of them, so 8 new CX10000s, nice shiny new top of rack switches, fully capable of all kinds of stuff, and they were paying the same amount as they were paying before, just by offloading the distributed firewalling capability from their VMware side of the estate onto the CX10000. So there's kind of 2 different pathways that we can deliver there as a quick hit. And then there's a longer term solution. That longer term solution, on the kind of mid left side, the real tall purple pillar, that's kind of the new baseline pricing for VMware. We've got this tool called Cloud Physics that you can deploy on your network, and it can start to analyze and give you real data, AI ops, give you data to start making intelligent decisions. It can start to analyze your VM usage. Are you using, do you need all those VMs? Can you optimize just with your existing, compute infrastructure? Are you able to, consolidate and maybe just get down, not pay so many cores and use it more efficiently? So that can get you a level of cost savings. Then you can move to the VM Essentials and get some additional cost savings by starting a migration plan over time away from VMware. Instead of paying per core per year, you're now in a socket-based approach. The other way we kind of put it in here is moving to PCE, where you're not actually owning the estate. We can own some of that virtualization cost, and we can also give you, a model where you're paying for what you use, not just to have a bunch of, high-performance stuff sitting around that might be idle 50% of the time. We can put that in there for you. And then the last part is putting in the CX10000 and migrating some of the capabilities over the CX10000. The analysis that we've done here, your mileage may vary or your kilometers may vary, 80+% decrease in cost over time as you kind of go all in this solution. So I'm getting kind of the 10-minute hook here. So I'll go through the next use case that we have here and leave some time for questions. This is kind of bringing everything together, and it's our ransomware remediation solution, or one of them, I should say. This brings in the strengths of the CX10000, the Zerto product that we have, as well as OpsRamp, and kind of brings all 3 of those together. And I want to say we did all kinds of high-end development to make this happen. We didn't do anything. These are just taking the products as they are and building a solution that delivers value kind of straight out of the box. And I'll kind of go through what that is. So we started out with very, very simple network here. Down at the bottom, above the red servers, these are a pair of CX10000s. We've got a microsegmented network out here So everything's working great. We've microsegmented it. We're beautiful. We're up and running. In here, we've got Zerto to go and kind of take a look, inspect these servers and the VMs and make sure nothing's going funky here. We've got OpsRamp to keep tabs on it operationally, and then we've got our orchestration suite for the CX10000. So we pulled together a demo to take just the inherent capabilities of these products and put them together and see what we could do from a ransomware perspective. So what we did is we simulated a ransomware attack where we use an application, we target a given VM, and we start to encrypt the files on that VM. Zerto sits there in the background, looks, detects this encryption event, and that's typically where the ransomware events are, is an encryption of your data, so they can hold it hostage and charge you a lot of money and give you a lot of downtime while you're figuring out, do you pay? So the cool thing here is once you start that encryption event, Zerto will detect it. It sends a flag up to OpsRamp. OpsRamp gets that flag and pulls the data that it needs to pull out of that alert. Things like what VM it is, what's the IP address, runs it through a script that it then sends up to the CX10000, and through the APIs, we're able to take that data, reconfigure the microsegmentation policies, and we actually segment out that culprit. And the demo that we do here, it's sub 1 minute to do this. So if you look at kind of current benchmarking for best in class isolation of an infected machine that's going through a ransomware attack, it's like 5 minutes. So this demo does it in sub 1 minute. More commonly, it's hours to days in a typical ransomware event. So we're kind of taking what can be days, maybe longer, maybe just in the hours, and we're bringing it down to 1 minute. Then we can use the capabilities of Zerto and get you back to a restore point, restore the data that was encrypted, and get you back that data on your own. The downside to that is you might have restored it to a point where it was already infected, and you might experience this ransomware event again. So what you can do is you can take this streaming telemetry data that we pump out of the 10,000, and you can do some deeper forensics in this data to see if you can recognize when day 0 actually happened. Detect an anomalous flow, that should never have happened, that might have been the day 0 event, and you can back up the restore point to a point prior to that and restore to a point that was prior to the ransomware. So again, this was just taking the native capabilities in each of these things and creating a solution for you guys that will detect and isolate out a compromised VM in less than a minute. So kind of cool capabilities that we have there. Many more things that we can do, but time doesn't allow us to kind of go through all these. So I really wanted to just highlight this one because it was pure and simple. Call to action I pulled together because we needed to, but I didn't know I was going to be the last presentation. So not sure if there's much time to go look at the demos. The key point here is there's a lot that we can do, both on the HPE side of the house, on the CX side of the house, the newly acquired Juniper portfolio, between firewalls, the AI networking, everything. Get in touch with your sales rep, have them come out, figure out what are your pain points today, and let's work with us to help build a solution, see some demos, put in a POC, and get the right equipment in your network to help you out of whatever bind you might be in. So thank you. I know we're at the end of the day. You guys are far more attentive than I thought you might be. Nobody fell asleep. So please, if you're not already a member of the Airheads community, go ahead and join. Oops. If anybody needs that QR code, I can go back. And probably most importantly from our side, please do fill out the survey. We look at those things. We make sure that we take your feedback and try and make these, materially as important as we can. I can't say I get any more exciting, but at least we, content-wise, can shift it and shape it to what you find most important. So first and foremost, thanks to everybody for showing up. All right, thank you.